All right, welcome back. Let's just real quick go over what we did yesterday, and then we'll finish our example and walk through a construction. So we don't have very much more to go. Yesterday we started talking about transformations, which are just some sort of changes, and we looked at the translations, and we sang Beyonce. To the right, to the down, to the down, to the, yeah. So poor Beyonce is probably, her ears are burning, and she's like, oh dear God, why? And then we talked about the translation vector, and we did this weird thing where we translated stuff and we didn't have any numbers, and we had to use our compass and protractor. And I know that for some this was weird, and so once we finish the examples today, we'll come back and we'll do a new construction a little slower, just so that it feels a little better for you guys. Okay? We ended our conversation yesterday on this example, talking about this translation, 6 to the left, 7 down, and we needed to write its translation vector. Any ideas? Yeah.
I don't really remember that I left, like.
Okay, yeah, you were left at the tail end.
So I don't know what's going on.
Okay.
I'll ask you later.
No problem. So let's just review this example real quick, and hopefully this will catch you up. So we had to draw this translation of this line, CJ, and we had to move it 6 units to the left and 7 units down. And when we did that, we ended up with this segment right here. We looked at the endpoints, the coordinates of C, and we found the difference between them, and we got this one here, -6, and this one here, -7. And so the question is, how do we turn this into a translation vector? Well, this moving 6 units to the left, is that an H number or a K number? H. Yeah, looking at your translation descriptions from the day before, horizontal is H. So this number is H, which means that this translation, when we're moving up or down, is K, a translation in the Y direction. So that number is K. Look back at your translation vector notation. Do you see the notation? The vector notation says this first number is H and this second number is K. So just substitute. And your translation vector is -6, -7. Make sense?
Yes.
All right. No, you weren't here. You're like, that made sense to me. I don't know what you're talking about. I have no idea what language you're in, but it made sense. All right. General questions on the writing of the translation vector.
What paper do we use? What the heck?
All right. Pass around some glue sticks. Glue stick, glue stick. Glue stick. Do you need a glue stick? Do you need a glue stick? Here's another one. Do you need another one? We're just going to glue one little thing. All right. Let's do the last example before we get to our construction. And that is going to be the last graph that you have in your little baggie.
My little baggie disappeared.
Your little baggie disappeared? Do you need one of these? I have an extra.
Maybe.
All right, you may need to pass this over to Miss Dakota. Does anyone else need one? There's another one there for Mr. Hector. And I have one more. And one for Victoria. So Victoria and for Hector. I don't have any more extras pre-cut up here. All right, the directions for this example are going to read this. Draw the translation of line segments LF by vector H, -7, -7. So we're given the vector notation for our translation vector. And it tells us where to move. I'm going to write it bigger here so that we can see it. Here's our vector notation. According to our template, our vector notation tells us the first number is h, the second number is k, which means what is the value of h?
-7?
Thank you. And what is the value of k?
-7.
Thank you. Now, is the value of h greater than or less than 0?
It's equal. Wouldn't it?
To 0? The value of h is negative 7.
Less?
It's less than 0 because it is negative. So h is less than 0. When h is less than 0, what direction are we translating?
To the left.
To the left, to the left. When the value of h is negative, you translate to the left. K,
K is less,
less than 0.
and then you'll be going up,
Look back at your translation descriptions.
down.
Down. Okay.
And then I can have you.
Okay.
I missed what I made, so we're looking great.
Okay, sounds good. All right, so we know we're going to move left how many units? 7 units left. The negative tells you which direction, and you're going to be moving down how many units? 7. Do it. Did I translate it into the right spot? Double check it. Make sure I did it right. You know me and the mistakes. They're real. As soon as you get the translation, go, yep, we did it. Yep, we did it. Yep. Awesome. Questions on using the translation vector to move when you're on a coordinate grid? Questions on how the translation vector is written, its notation?
Hi.
Yes.
I'm confused on the one where you do the box.
When I do the boxes around it, okay, I'm going to shift it down just a little bit so that we can see some of those boxes.
I'm talking about on the
This one?
Yesterday, the previous example.
Right, this one.
No, yesterday.
The construction.
The construction.
The construction, okay, we're going to do another construction in just a moment. Yeah, we'll do a brand new one so that you can see it. While we're waiting, because I still see a few people copying stuff down, what's your question on the construction? Just a general, how do you do it?
Yeah.
Okay. All right, so let's go ahead and figure out how to do it. I'm going to set up for an example. So go ahead and write your example off to the left and title this section Translation Construction. Okay? Translation Construction. Now what a translation construction does is it copies some segment to a different location based on whatever the translation vector we're given tells us. Okay? So I need to have first a segment to copy, and then I need to have a translation vector to copy from. Now I'm going to make use of these blue lines here as guidelines because they're all parallel, and it's going to help us find those congruent angles faster. Okay? So we're going to do that. We're going to make sure that we have that lined up. What you'll see when I hand you the, hey, do this translation thing, is I will provide guidelines for you. And then you don't have to worry about it. You just follow the guidelines. I'll eventually take the guidelines away as you get better and better at it. So start on one guideline and draw yourself a segment that's going to end on some other guideline. There it is. Hi, come on in. Now, I've drawn this particular segment very far to the left of my workspace and very to the top of my workspace. So my vector, when I create it, has to go down and to the right. Because if I go up, I'm going to run into this stuff. And if I go to the left, I'm going to run into this stuff. So my vector has to go down and to the right. So start again at another guideline. And then go down and to the right some distance, whatever you're feeling. And draw your vector.
When we draw the vector,
Mhm.
should we go to another guideline or
You do not have to go to another guideline.
would it be easier to go to?
Not necessarily. With the segment, yes, make it go guideline to guideline. With the vector, just where you're starting it from should be on a guideline. Everything else doesn't matter. I'm going to darken my guidelines just so it's a little easier to see them. You don't have to, though you're welcome to do so. Okay? So those are the guidelines that I'm using. And what my construction is going to have me do is I'm going to construct a congruent angle congruent to this one. And I'm going to construct that one here and here. Those congruent angles, ladies, have the discussion later. Those congruent angles will tell me in which direction this vector is facing. Once I find where the vector is facing, I will then figure out the distance the vector is traveling in, and that will tell me where the point ends up translating to. Okay? So congruent angles first, take your compass, put it on the start of your vector, and draw an arc, and you want to choose a radius that is almost as big as your vector. If you've got a very narrow angle here, see how this space right in here isn't very big? You want to make that arc as long as you can manage to get it without making it as long as the vector, because we need that vector length for something else. Okay? If you have a very big angle between this reference and where you drew your vector, no problem, you can make this radius shorter. Okay, so I'm going to create this arc, and I need to make sure that this arc intersects both my reference guideline and my vector. Okay, everyone have that arc drawn?
Yes.
Okay. Keeping the same radius, bring this over to one of your endpoints, the one you're translating first. And now I'm going to try to copy this arc. It looks like this arc is going to travel at least one guideline and then a little bit more. So when I draw my arc, I'm going to make it go about the same amount. So I did one guideline to the next, and then I went past it. The next thing that I need to grab is this distance right here. Right there, that distance. So find that distance with your compass, and if it's too small, okay, which could happen, if this distance is too narrow and you're like, I can't handle the compass being that small, then you need to make this radius bigger. Okay? Once we have this distance, you're going to place your compass right here. And you're going to mark off the distance where it intersects the first arc that you drew. The vector is going to go from the end point of the segment in the direction of that intersection that you just created. So take your pencil and draw a guideline for your vector going off in that direction. You want to make it definitely longer than your actual vector.
Where'd you get the little dash on the
This
reference?
one?
Yes.
That is this distance. Yeah. So my vector is shooting off in that direction. Now I need to figure out how far. Congruent segments, if I treat my vector as a segment, that is the magnitude of the vector. That's its distance. It's how big it is, how far it goes. I'm going to copy that distance by setting my compass to that distance. And then I'm going to move my compass over to the endpoint that I'm moving. And I'm going to set an arc down to intersect that ray that I created, showing where the vector was going toward. Where those two things intersect, right there, that's the end of my vector. And so that is where this point is being translated to. Questions? It's a little crazy?
Yeah, it's pretty easy.
Oh, it's easy. Okay. Oh, good. I just heard it's easy. I heard Z at the end, you know? So my brain's like, crazy? Yes. We're going to repeat with the other endpoint. All the same thing all over again. This one's already done for me. So I'm going to go ahead and set that up. Set my arc. Find this distance. Copy it here. Okay, where am I losing you?
Just like all the lines.
Okay, so visually it gets confusing.
Like okay, so you, from the segment, that thing,
The vector?
you just put it on A and then you put the point, and then on B you put the point also.
Uh-huh. So we're right now on A, the last thing we did was we grabbed the vector length, and that got us from A to A prime. And right now these two marks that I made are this reference line and then this distance right here.
And you just made up the
This arc? Yes. I put whatever was comfortable. Okay? Yeah? All right. Going to give my vector its direction. So from B, going through this intersection point I just created, my vector is going somewhere in that direction. I need to figure out how long. So I'm going to grab the length of my vector. And I'm going to copy it here, centered at B. Yes? Yes? This is the length of my vector. That's where my vector ends, and that's where the image of B, called B prime, will end up. I moved the endpoints so that I could take my straight edge and connect them with a straight line to create the segment being translated.
How do you have the second line again?
This one?
A.
This one? I connected the points.
So what if like the little after?
This one?
Yes.
Oh, how do you do it if like there's no line?
If there's no guidelines,
Yeah.
you'd have to create guidelines. You're not ready for that yet. So when I ask you to do this, I will provide guidelines for you until I get a good section of the population doing it comfortably well, repetitively with the guidelines, and then I will show you technique to create them and take the guidelines away. And you'll be asked to create the guidelines.
What is that?
Yeah. All right. Any questions on the construction? Are we feeling a little better about it than we were yesterday? I got some thumbs up. Awesome. All right. Thank you very much. The rest of the class period is yours.